let's now develop a simple model for counters. So we're going to define a classical counter and then define the relevant attributes, constants, which I'll show you how you can do as a practice, good practice, and also constructor, mutators, and accessors. Okay, so now let's go under app, under Java, and go under this package over here. The same package as the activity file. Okay, we're just gonna add a new Java class. So right click on this package here and then say new and then Java class. Okay, we're gonna have counter. Remember the naming convention for Java classes will be capitalized words for compounds, for compound words. Okay, and then the visibility modifier, just leave it as default. Okay, and then we'll say OK over here. Okay, so now let's say we're going to define a simple class for counter. Let's say the counter we got some defined maximum and minimum value. Okay, let's just make them constant for now. You can say final integer, let's say integer counter just to be simple. Final int and then minimum of counter. Okay, let's say for now the minimum can be down to -2, for example. You can change that as you like later on to actually see how your app's behavior might change later. Okay, so now we also remember the naming convention for constant, which will never change its value once it's initialized. So it would be all capitals word, and for compound word, it's going to be separated by underscore. Okay, that's the naming convention for constants. And also we got final integer maximum of counter. Okay, let's say it's up to 3. So the counter's value will be -2, -1, 0, 1, 2, and 3. So 6 possibilities. Okay, and then we're going to have a constructor. Okay, so now if a constructor is going to be of the same name as the class name. Okay, and then we can just have it's kind of up to you. For now, I'm just going to make it simple to say, oh, after the before this, we're going to declare attributes. So let me just make some comments for you. So now these will be constants. Okay, so these constants can be used by any methods in the class. I'll talk about the scope of variables in just a moment, very briefly, so you can have some idea. So now we also got attributes over here. Okay, so attributes. In this case, we just have some value of the counter. Okay, the integer value of the counter. Okay, now when we go to the constructor over here, so here you have a choice. You can either say you can have integer, let's say just value over here, which will be some input you have to pass when you call the constructor of the counter class. In which case you can try to set some initial value of the counter value, or you can simply just set it internally. Okay, let me just make it simple. You can do this version over here by yourself, like how you can set up a name for the person. Okay, let's say over here, I'll simply say whenever you try to create a new counter, the default value will simply just be 1. Okay, and you can, apparently 1 is in between the minimum and the maximum. Okay, that's what I can do. I can say the value, you can say, okay, this, which means the current context object, this value is assigned to just 1, just initial value. Okay, it's just as an example, which means we don't any user of the counter class, if they want to create a counter object, they have no choice about the initial value for the counter. It will always be 1 as for now. Okay, if you want to change the way the counter works, you can feel free to do it as an exercise. Okay, let me just put it here. So this is the constructor. Always initialize counter's value as 1. Okay. Okay, let's fix the typo here. Okay, so that's the constructor, and then let's have 2 mutators. Okay, mutator means how we can change the value for the counter. Let's have increments and decrements. Okay, mutators. Okay, mutators simply means they do not return anything. Okay, they are simply going to make some changes to the attribute value. Okay, so now in this case, we're going to say void increments. Okay, and somehow this increment method will be somehow will be eventually called by the controller button increment clicked. Okay, but we'll see the connection in the next video. Okay, so this will be increments, in which case you'll be very easy. We can say this dot value plus plus, which is equivalent to basically this dot value is assigned to this dot value plus 1. Okay, remember the this kind of shorthand that we talk about in the lecture. Okay, similarly, we're going to have another mutator which will decrement the value for the current counter. So you can say void decrements, and over here we can say this value minus minus. Okay, it is going to be equivalent to this value is assigned to this value minus 1. Okay, equivalent. Okay, and now we're going to have also some accessors. Okay. Okay, let's say accessor methods. Okay, so we're gonna show you actually 3 different ones. Remember the toString method that we defined in the BMI example for the person class. That's one typical example. Also, we're gonna show you to say let's have some Boolean methods which you may not have seen so far. Okay, which means the accessor method is gonna tell us the current counter value is it too large or too small. Okay. Oh, is it already reaching the maximum or is it reaching the minimum? Okay, basically that's what we want to say. Because if the current counter's value is already reaching the minimum, in that case, we should not do any further decrements. Similarly, if the current value is already reaching the maximum, that means we should not actually do any further increments. Okay, that's something you will see how this method can be called from the controller. Okay, let's say first of all, Boolean. And then we'll say has reached maximum. Okay, and then basically we don't have to take any further inputs over here because we can simply use the this value to decide whether the current counter has reached its maximum. Okay, so this is easy. The simplest way you can do this is simply say return this value equals, which means we want to compare 2 values, and then you can say maximum of counter. Okay, that's the simplest way you can do it. Alternatively, let me put this in the comment, show you another way to do it. You can choose which one you prefer. What we can say, since we know we're going to eventually return a Boolean, we can say Boolean result is equal to something, right? So this right-hand side of the assignment is going to be some Boolean expression. And the Boolean expression is going to be based on whether the current value of the counter is equal to the maximum already. We can say this dot value is equals maximum of counter. Okay? And then we can say return result. Okay? So these 2 lines over here are completely equivalent to this single line over here. So which one to use is completely up to you. Okay, if you get more comfortable with Java, you can feel free to be as concise as possible. Okay, so now we have another symmetric accessor method over here. We can say Boolean has reached minimum. Okay, in this case, we can say, let me just do the simplest way. Okay, return this value equals the minimum of counter. Okay, let's have one more accessor, which is a toString method that we have been practicing. You can just type toString. Okay, and then the Java code completion. So don't worry too much about this override tag over here. So we will talk about more. We may be able to talk about this override. What this means. It has something to do with inheritance, which is an advanced topic which we may not be able to cover in 1022. But anyway, so you just have to type toString and then use a code completion to help you. Okay, so now we can simply say string result is initially an empty string. Eventually, we're going to return result. Now in the middle, we're going to do something to the result to accumulate it to the string value that we would like to return. We can say result plus equal, which is equivalent to result, is assigned to result plus something. Okay, result plus equal. Let's say we can say counter value is, okay, and then we can say plus this dot value. Okay, like that. Okay, that's what we have. Okay, very simple toString method, but of course for your particular app, you can try to make the toString method return value more sophisticated. Okay, so now let's remember that we learned about test-driven development, which means as soon as your class becomes testable, before you go on further, you want to make sure somehow your all your methods in the class are somehow working. Okay, why don't we try to illustrate that very quickly? Okay, what you can do is, let's now right-click on the package over here. Let's create one more class for tester. Okay, so now you can call that counter tester. Okay, and then we are going to define the main method here, so we can actually execute the methods and see the output on the console without any physical connection to any tablets. Okay, so now I'm gonna say public static void main string brackets and then args. Of course, you don't have to memorize this header of the method. You can just use it. Okay, so now we can say sout and then enter. It's going to give you system out and print line. Okay, you can say after initializing a counter. Okay, like that. So now notice that the way we're going to manipulate the counter objects in a tester is going to be very similar to how we're going to do that in a controller. Okay, that's why it's good to actually do some test-driven development to know that whatever method that you will be calling in the controller are guaranteed to work. Okay, so now we'll say, first of all, let's create an objects counter. Counter, let's just call it C, is assigned to new counter. So you should really know the syntax very well for creating an object. You will be tested in the course about how to create an object. Okay, counter C, and then we can say let's now print out the value for the counter as out over here, and then we can say C dot to string. Okay, now also we want to know if the counter value is reaching its minimum or reaching its maximum. Okay, what we can do is, let's say as out. Okay, we can see counter has reached its minimum. Okay, and then we can say plus over here. Now we can plus some Boolean expression value. Okay, you can say C dot has reached minimum. Okay, similarly, I'm just going to copy and paste this line here, and then we're going to say, okay, let's copy and paste. Okay, and then counter has reached its maximum. And then here we're going to call the relevant method has reached maximum. Now remember the initial value for the counter, as we let's recall, the initial value for the counter should just be 1. 1 is neither -2 nor 3, so both should be false. Okay, why don't we try that very quickly, and then we'll do some increment and decrements. Okay, let's try that. So now let's right click on this particular tester over here, and then we'll say run counter tester main. Okay, let's run that and then wait for the Gradle to build and see what's the console output. Okay. Okay, let's see that. Of course, once we see the output there, you should also try to run a debugger later to actually use a breakpoint debugger to see exactly how the methods are executed. Okay, so now you can see the output is over here. After initializing a counter, counter value is 1. So this output over here corresponds to the output, the return string value from C.toString. Because the initial value is 1, so it's going to say counter value is 1. Okay, remember in the counter class, this is how we define the toString method over here, right? We say counter value is this value. And over here, the context object is actually C over here. That's a context object. So the this over here is replaced by C, which has the initial value 1. That's why we had counter value is 1. And then counter has reached its minimum false, because 1 is not equal to -2. And also counter has reached its maximum is also false, because 1 is not equal to 3. Okay, let me show you one more example over here. Let's say we are trying to increment from 1 to 2, 2 to 3, in which case we will have reached the maximum of the counter. And then I'll leave to you as an exercise to see how you can increment or you can decrement the counter value so that it has reached its minimum. Okay, let's try this. Okay, S out, and then we'll say, let's say increments counter value from 1 twice. Okay, which means from 1 to 2 and 2 to 3. Okay, what we'll do is we'll say C dot increments and C dot increments. Okay, now let's simply just repeat these two lines over here. Okay, and then paste it here. And let's re-execute this class over here. So we just go here to play. Okay, we're gonna run the counter tester again. So let's see what's gonna happen. Okay, you will see that over here you can see increment counter value from 1 twice. After which you will see the counter value. Oh, before that, okay, maybe I can do one more thing over here. Let's see that more clearly. Okay, copy this line over here. After increment, we can also see what the counter value is. Okay, to string. Let's try one more time. If you do that over here, you will see that increment counter value from 1 twice. So after which counter value is 3. 3 is actually not the minimum minus 2. So that's why it's false. And the counter value 3 is equal to exactly the maximum, which is 3. So that is why it is true. Okay, so you should really know why. Okay, so now as an exercise for you, I'll put it here. Exercise for you. Decrement the counter value so that the return value of C dot has reached minimum returns true. Okay, that will be as an exercise for you. Okay, one more thing I would like to show you very quickly. How do we run the debugger and breakpoint? So debugger and breakpoint are really a very powerful tool for you to use for test-driven development. And also, whenever you really run into trouble or run into any weird or wrong output value, you should really try to use debugger either from the tester or from the controller. Okay, let me just show you one more time. So for example, let's say we are trying to put a breakpoint over here. Okay, you can just put it beside the code that you would like to pause for the execution. Okay, after this, after we put a breakpoint, we're going to run the debugger over here. Okay, you can see rather than play, we're gonna say debug over here. So let's debug. So the execution is going to pause right before. You can see now it's actually highlighted in blue over here. That means we have not yet declared and created this counter object right before it happens. Okay, so now what you can do is you can step into it. For example, if you try to step into it, you're going to see exactly how the counter object is going to be created. Okay, why don't we try to step into it? If you say over here, step into as opposed to step over. Step over means you're gonna execute that line without stopping. Step over means you're gonna walk into that method and see how to execute that method line by line. Let's step into it. If you say step into, you will see that now we are in the context of this counter class. Okay, and then inside this constructor over here, there's only one single line. Simply this dot value is assigned to 1. Okay, if you try to execute this line over here, you will see that at the moment, this dot value has not been assigned to 1 just yet. It simply just has its default value for integer, which is 0. So we're going to execute this line here and see what happened. Okay, let's step over. Okay, okay, the reason that we have this is because we also got another 2 constant values for the class to be initialized just for once. That's why we also got these 2 lines. Okay, let's just see that. Okay, and then we say step over this, step over that. So now you can see that for this particular class over here, we also got 2 constants over here, minimum and maximum being -2 and 3. Okay, and then we are going to execute this line over here. At the moment, it's before we execute this line. After this, we can expect to see this value should become 1. Okay, let's now step over. If you step over, you can see that this dot value has become 1 because we just executed this particular assignment. This dot value is assigned to 1. Okay, hopefully you follow. But you really try to execute this for as many times as necessary for you to understand what's going on for the constructor. Okay, let's now step over again. So now, if you actually go again over here, and then when we say system.out.println c.toString, okay, somehow Android Studio is very useful. It already tells you when you're saying C, it tells you c.toString is going to return this particular value. Counter value is 1. But how does it know? But you better just step into it and see how exactly this can be executed. Okay, why don't we just try step into? If you say step into, now we are back to the counter class again, and now we are in the toString method. We're gonna execute this line by line. Let's see. Watch very carefully. Okay, before I finish this video. Okay, first of all, we're going to step over. That means we have executed this line here. So this line here has declared a string variable called result, which has been initialized to an empty string value. Okay, that's why you can see over here, result is an empty string. Okay, and then we can say, so what we are trying to do is, we are trying to say result plus equal counter value is, and this dot value. Okay, what we can do is, we can simply just step over. Okay, if you step over, you will see that this dot value currently, if you move your mouse over, you will see that it also shows you this dot value is 1. Okay, so it also shows you what this variable is currently. Okay, and then result has been accumulated to counter value is 1. Okay, that's why you can see the result has changed from empty string into this particular string. And then, so now we're going to return this particular string. Okay, so now let's step over again. So now we're back here. And then you can simply just do the following. Okay, so now you can see that this is right before we try to increment the first time. So that's why it's showing you at the moment counter value is just 1. Okay, if you try to step over, so now you can see before execute the second increment, the counter value is 2. And then if you try to step over again, so now counter value has become 3, which reaches the maximum. Okay, so that's kind of the thing you want to really go over for as many times as necessary for you to understand how the breakpoint debugger work. Okay, so now so far, let me stop the debugger and recap very quickly. So let me stop this. So far we have defined a very simple class for the model called counter. And the counter has only one single attribute which might change its value, which is called value, the counter value. And then these two things are simply just the constants for minimum, like upper bound and lower bound for the counter. You can feel so the reason that we declare these two values as constants rather than just using, for example, over here, you can see has reached maximum. What we could have done was we can simply replace this this constant over here by just 3. So but why did I actually use this maximum max of counter and also min of counter over here? It's simply because for reusability of the code. Think about this. Let's say at this point, I tell you that let's change the requirements for the upper bound and lower bounds. Let's say the new upper bound should be 5, and the new lower bound should be -5. In that case, I don't really have to go to the code over here to change this to 5 and change this to -5. I don't have to. I can simply just go over here and change this value over here to be -5 and change this value to be 5, and everything else will just be reflected accordingly. Okay, now imagine a much more complicated class in your case if the same name constant might be referred to in multiple places, in which case you don't have to replace every occurrence of the same name constant. You can simply just change only one place. Okay, and the multiple places of occurrences will just be reflected accordingly. Okay, this is a little bit more advanced programming technique. Hopefully you can pick it up gradually. Okay, so we got these two constants here, and also we got this attribute over here, and then we have our constructor. We got two mutators which will modify the values for the attributes, and that's why they return just void. And then we also got 3 accessor methods which does not return void, they return something. So this it can be Boolean type or it can be string type. Okay. So that's about the model class we have developed, and also we show a tester over here to see how you can create a counter object, how you can call the accessor method like a toString, and has reached minimum, has reached maximum, and also we show you how you can call a mutative method increment, and also left as an exercise for you how you can call decrements. Okay, so that's about the test-driven development. I also hope you to learn. Okay, in the next video, we'll show you how you can make connection from the controller to the model.